Hello everybody, in this video we're going to be continuing to work on that Unit 2 Ellipses practice set page. So starting with number 5, similar to the one we just did, we're going to start by determining the direction or the orientation of the ellipse. So this one, our larger number, 81, is under the X. So this is going to be a horizontal ellipse. So what this also tells me is that 81 is a squared, and so 9 would have to be b squared. This tells me that my a value is 9 and my b value is 3. Next, we're going to find the center of this ellipse. So we've got 1 inside with x, -4 inside with y. So remember, when we pull out the h and k value, we switch the sign from the equation to the coordinate. So this would be -1 and +4. So opposite signs as they appear in the equation. So my foci, these, excuse me, are C units away from the center. So I'm actually going to draw a kind of rough sketch of the ellipse we are looking at to kind of help me figure out how to solve for it. Excuse me, and actually before I do the sketch, let's go ahead and find the C value first, or how far the foci are from the center. And then, just like in this problem, we'll determine if that C value is going to be left and right of the center or up and down from the center. So remember that formula for finding the C value is C squared equals a squared minus b squared. So again, it's not the Pythagorean theorem, it's got that minus sign there. So plugging in our known values, we've got c squared equals our a squared, 81, minus our b squared, which is 9. Now 81 minus 9 gives me 72. So if c squared is 72, square root, then c is equal to plus or minus the square root of 72. So remembering that plus or minus is an important little detail. And also take a look at our c value here. There's something that's not quite right about the square root of 72. What we need to do is simplify what is under the radical by taking out the biggest perfect square that we can. So sometimes 9 is the first of the perfect squares to jump out at you as a factor of 72, but your biggest perfect square is going to be 36. So my perfect square factor of 36 is 6, and that leaves me with radical 2. Now, if you're wondering, how can we split this radical like this? You're essentially doing a little radical factor tree with it. So we break it down into a perfect square factor that's easy to take the square root of, times the factor that's left over, which stays under the square root. So C equals plus or minus 6 rad 2. So that is my C value. So now we know that the foci lie on the major axis. So what we want to do is kind of draw a little picture to help us figure out which direction we are going to move from that center point. If we move left and right of the center point, the X value will get plus or minus 6 rad 2. But if we go up and down from the center, then it would be 4 plus or minus 6 rad 2. So similar to this one, where since it was vertical, we add it to the Y value of the center. So I'm going to go ahead and sketch out what this would look like. My center is at -1, 4. So I'm just going to make the center right there. My major axis is horizontal, and my A is 9 units. So I'm going to move 9 units this way and 9 units that way, giving me my vertex and my vertex. Now my minor axis, since this is a horizontal ellipse, goes in the opposite direction, or vertically. So because my B value is 3, I'm going to go 3 units up and 3 units down from my center. And that would give me my co-vertex points. So from there, I can sketch out what the ellipse would look like, trying to make it look more like an egg and not like a football. So try to make it as round as possible. And my foci always lie on the major axis. So here, my foci were vertical, since this was a vertical ellipse. Here, since my ellipse is horizontal, our foci are going to lie horizontally to the left and right of our center. So what this means is we are going to move left and right of the center by adding and subtracting that C value from the X part of our center. So my foci would be at -1 plus or minus 6 rad 2. And then that Y value of 4 would stay the same. Again, the foci, the center, and the other foci are all in line with each other, so that's why they all have the same Y value. Now, sometimes students will look at this and go, ooh, can I add the -1 and the 6 together? We actually can't. So because this has an irrational part to it, and this is solely rational, we actually can't do anything to add those together. So that's as simplified as the foci will go. Next, we're ready to find the major axis, which I can see from my diagram is 18 units long, or 2A, so 18. And then my minor axis is 6 units long, because it is equal to 2B. So one of the things that does get kind of confusing is it 2A? Is it A squared? Is it just A? So it's A squared in the equation. It's A when we use it for graphing to figure out how far those vertices are from the center. And then to find the major axis, it is 2A. I strongly recommend, especially on the My Math Lab, doing these little sketches so you can visualize what each of those parts is like. So on your own, I would like you to go ahead and try number 6.